In this scenario, we'll be discussing how DNA replication occurs when you cut your finger.
Helicase is an enzyme that unwinds the DNA helix ahead of the replication machinery. The helicase separates the DNA to form a replication fork at the origin of the replication, where DNA replication begins. Replication forks extend bidirectionally as replication continues. Topoisomerase are enzymes that participate in the overwinding and underwinding of DNA. Single-stranded binding proteins bind to and stabilize single-stranded DNA during the replication until the single-stranded DNA can be used as a template for a new strand to bind to.
RNA primase. The job is to synthesize a primer for replication to start. First, it waits for a helicase to create a replication fork, then it comes behind helicase to lay down a primer. RNA primer. A primer is a short polynucleotide segment that prepares the way for DNA replication by helping DNA polymerase to get started doing its job. A CIte clamp protein allows DNA polymerases to remain attached to their DNA template. This way, DNA polymerase is allowed to synthesize long stretches of DNA efficiently without coming off the template.
DNA polymerase III contains its own site of proofreading and can recognize mismatches after it lays down the nucleotides. If an incorrect base is paired, it is immediately kicked out, but this very rarely happens. The error rate is about 1 in 100 million. DNA polymerase I. After DNA is removed because of a mistake, polymerase I fills in the gap, but it does not join the nucleotides together. That is the job of DNA ligase. DNA polymerase I also removes the RNA primers and replaces them with DNA bases.
In DNA replication, the DNA bases move in a 5' and 3' end. The leading strand, which moves in a 5' and 3' end, moves in a continuous way. The lagging strand, on the other hand, cannot move in a continuous way because it moves in a 3' and 5' range. And DNA bases can only move in a 5' and 3' range. Thus meaning that DNA bases will be laid out in chunks called Okazaki fragments. Each fragment is started by a primase that lays down RNA primer, and then a polymerase III lays down DNA bases in a 5' to 3' motion. Polymerase I then comes in and replaces the primer with DNA bases. The new strand of DNA is semi-conservative, meaning that one strand of DNA is old, which is the parent strand, and one is new, which is the daughter strand. They move in opposite directions, which mean that they're anti-parallel.
DNA ligase is a very specific enzyme. It joins together strands of DNA by catalyzing the formation of the phosphodiester bonds. Ligase is used in DNA repair and DNA replication.